As a quick review and to give you some examples, I thought I'd make a video to get you started on derivatives of exponential and logarithmic functions. There are two rules you need to know. Really, that's the base a to the power x, how to find that derivative or what that derivative is, and the derivative of log of any base. E to the x and natural log of x come up quite a bit, so we should also say those derivatives. These are the four things you'll need today, in addition to things like power rule, chain rule, product rule, quotient rule, things like that. The derivative of e to the x is e to the x times the natural log of e, which I won't write. The derivative of a to the power x is a to the power x, natural log of the base a. The derivative of natural log of x is 1 over x. The derivative of log base a of x is 1 over the x times natural log of a. We can generalize these things as well. For example, over here on the left, if you had e to some function, that derivative is going to be e to that same function, and then chain rule applies, so you'd have to multiply by the derivative of that function. Likewise, what if we had natural log of, let's say, x squared? You could say the derivative of natural log of x is 1 over x, but you could also say the derivative of natural log of the input is 1 over the input. So the derivative of natural log is 1 over the input. That input is x squared, which has a rate of change of 2x, or we could say we're using the chain rule. And that simplifies to be 2 over x. So, excuse my handwriting, it's not the neatest. Find the first derivative of 5 natural log of x with respect to x. What structure do you see? Well, 5 times the natural log of x is going to have a derivative of 5 times the derivative of natural log of x. What's the derivative of natural log of x? 1 over x. Let's rewrite that as 5 over x and be done. What about the derivative of log base 2 of t? I guess with respect to t. So I guess I'll use the notation s prime of t. And, well, the derivative of natural log is 1 over the input. So I know this derivative is also sort of like 1 over the input, but you also get an extra natural log of that base 2 in here. That's the whole thing. Okay, now we're getting a little bit more complicated. So g of x is cosine of x times natural log of x. The first thing you're going to have to deal with is the product of two functions. I'm going to leave a little bit of a space. So the derivative of a product of two functions is the first function, that's cosine of x, times the derivative of the second function, plus the second function, which is natural log of x, times the derivative of the first function. The derivative of cosine of x is negative sine of x. Let's go back and figure out what we skipped. First function, derivative of the second function. What's the derivative of natural log of x? That's 1 over x. Let's rewrite g prime to make it look a little bit prettier. So g prime of x is going to be cosine of x all over x, and then I'm going to write minus natural log of x sine of x. And I want to make it super obvious that natural log of x and sine of x are being multiplied, so I'll put parentheses around it. Okay, what about it? We have capital F of x is natural log of 3x. You're going to need the derivative of natural log of x, and you're going to need the chain rule. The derivative of natural log of something is 1 over that something, or 1 over the input. Our input is 3x, which has a rate of change of 3. Or you could say we use the chain rule. That simplifies to be 1 over x. All right, last example, we're going to find the first derivative of s with respect to t. We're given natural log of e to the power t minus e to the power negative t. You might think you can break apart this natural log, and you might be able to, but probably not in the way you think. You might be thinking that natural log can be combined, and that's true, but logarithms are exponents. And if you're subtracting exponents, you'd be able to combine them using division. We have a subtraction inside the natural log, so that idea does not apply to this case. So we're going to use the chain rule first. The derivative of natural log of something is 1 over that something. Okay, the input is e to the t minus e to the negative t. So we're going to have to use the chain rule multiplying by the derivative of that denominator. The derivative of e to the t is e to the t times the natural log of e minus the derivative of e to the negative t, which is going to be e to the negative t chain rule times a negative 1. So, oh my gosh, I realized I was writing an x. What do we end up with? E to the power t plus e to the power negative t over e to the power t minus e to the power negative t. You can't simplify any more than that, so that's a good stopping point. Maybe we should go back. So I had said, let's do something off to the side here. Let's say we were just looking at e to the negative t. What's that derivative? Well, we can think about this as the chain rule. So the derivative of e to a power is e to that same power. That power is negative t, which has a rate of change of negative 1. So you could think about that as, bring that negative out front, e to the negative t with a negative out front. Hope this helps.